All right, so we left off last class talking about economic models, right? And how we have to parse out the relevant parts and the irrelevant parts so that essentially we can pull a lever and we can try to figure out what happens when we pull that lever, right? We have to isolate the impact so that we can, essentially prove some kind of causality. Now, whenever we're doing, so all of these different models, right, we end up having some decision pitfalls, right? So we're going to go ahead and go over those real quick. 3 decision pitfalls. And so the reason why we have these pitfalls is because economic analysis only predicts likely behavior. So we find that there's about 3 general cases of mistakes. And so the first one of those is measuring costs and bennies as proportions instead of as absolute amounts. So what do we mean by this? Well, would we walk to town? Again, that kind of thing. Would we walk, or maybe, would we drive to Rapid City? It's probably a better case than would we walk to Walmart, right? Would we drive to Rapid City to save $10 on a $25 item? And then asking the same question, would we drive to Rapid City to save $10 on a $2,500 item? For the most part, we're willing to do this, right? Like saving, that's like a discount of almost half, right? And so again, we're measuring it as proportions instead of the absolute amount. So if we are entirely rational beings, right, which again, that was one of the assumptions that we made last time, that we have well-defined goals and that we do our best to try to achieve those goals, then we would drive to save that $10 regardless of what it's on, right? Whereas we're way less likely to drive to Rapid City to save $10 on a $2,500 item, right? So this is the first mistake that we constantly make, right? And part of this is kind of built into us, right? It's like at McDonald's and other places like that, right? The cost of the fries increases or does not increase that much, right? And so the cost difference between getting like a small and a large is a way better value in terms of like pound of food per dollar, right? And so they know that everybody's doing that kind of calculation, and they're pricing things in such a way to really get you to order more than you actually need to eat or want to eat or is healthy for you to eat or whatever the case may be, right? So that's our first decision pitfall, right? And it's exploited lots by marketers and other kinds of people that want to sell us stuff and take our money, right? The second one, the second pitfall. The second pitfall is when we ignore implicit costs. And so, again, we have to always consider all of our alternatives, right? And so a lot of times, if you say win a free concert ticket, you have to ask yourself, is it really free? Right? Even, so you got to pay for the gas to get there. There's the wear and tear on your car. There's, food and drinks and stuff that you're going to be buying while you're there, maybe some merchandise or whatever, right? But also, does going to this concert make you give up some other great activity? So, you know, if I get a free pass to go snowboarding this weekend or something like that, right? You know, not only do I have to keep in mind the fact that, you know, I got to rent a board and boots or all this other kind of stuff, but also like that's time where I don't get to go to the trampoline park with my daughter or whatever the case may be, right? And so, you know, I have to consider the implicit costs, not just the explicit ones, the ones where I'm writing checks or I'm using my debit card or I'm paying somebody with cash, right? Those are all explicit costs. Implicit costs are the trickier, more subtle types of things. So oftentimes we ignore them. And our last pitfall is when we fail to think at the margin. What do we mean by thinking at the margin? So we oftentimes will talk about what are called sunk costs in economics. Sunk costs are costs that cannot ever be recovered. Period. So if you attended the first year of law school and you hated being a lawyer, you hated everything you were learning, going to the second year of law school just because you already spent the money on the first year of law school is not very rational, right? But we end up doing this type of behavior a lot, right? One of the best examples that we have of this pitfall is when we eat too much at an all-you-can-eat restaurant. Right? We're trying to get that best value for our dollar, right? And so we think that that is going to be consuming more. But what actually ends up happening is that at a certain point, consuming more actually makes you more discomfortable, right? You know, you might get heartburn or acid reflux, or you might just feel bloated or sick or whatever the case may be, right? So at a certain point, eating more is not to your best advantage. And so instead of thinking about, oh, I'm going to go into this all-you-can-eat restaurant and I'm going to eat as much as I can, which is kind of thinking about it as at the whole, you're instead thinking about, does the marginal cost of going for another plate, is that greater than or less than the marginal benefit? How much am I going to enjoy that extra plate compared to how much discomfort that extra plate of food is going to make me? I did this the other night eating chanterelle cake. I ate too many slices of cake at a birthday party. And the next morning I was like, oh, that was not right. But that was also just, you know, intertemporal, right? I was kind of giving up future discomfort for greater utility or whatever consumption at that moment. So this one also I like to talk about a lot in terms of movies, right? So how many times have you like gone to a movie in the movie theater and it sucks and you're like waiting for it to get better and it doesn't get better? Well, I just leave now. I just leave the movie. Like everybody I know that I go to movie like knows this about me. They're like, okay, like, you know, and I mean, like if it's somebody I don't know that well, like I'll sit there. Like it's like if it's like girlfriend's kid or something like that I meet, you know what I mean? Like I'll be polite. But if it's like a friend or whatever, I'm just gonna be like, hey, I'm out. Like you could stay for this, but I can't. Like this is terrible, right? And I know that the money's already gone. I can't get the money back. But I can get that extra hour of time back instead of sitting there and hoping for it to get better and just sitting there because I paid for it and gosh darn it, I'm going to get this 2 hours of entertainment out of it. You know, if I'm not enjoying myself, I just leave. So again, it's difficult because we're very conditioned by marketers and everything else, right? To eat more and, you know, get the value size fries and the value size Coke and everything like that, right? But marginal analysis is really going to end up yielding you greater utility in the end. And so let's go ahead and talk about that marginal analysis. So when we're talking about marginal analysis, right, we have to make some definitions. And, you know, the first definition is to talk about marginal costs. So marginal cost is the increase in the total cost that results from doing one more of something. So we're just going to kind of be very generic here. When we talk about the average cost of something, that's different than the marginal cost. The average cost is just like any average. It's going to be our total cost divided by the quantity, whatever that, however many things we're doing, however many coffees we're making, however many lemonades we're making, however many auto repairs we're making, or whatever the case may be. Marginal benefit, oh, I can't see that one very well. Is a little bit trickier because we don't have a very good way to figure out, like, to enumerate benefits, right? Cost is simple. It's like what you paid for it, right? But it isn't that simple. Why? Pitfall number 2, we ignore implicit costs. Implicit costs are actually very difficult to put a number on. But in marginal benefits and total benefits are also very difficult to put a number on. Marginal benefit is the increase in your total benefit or total utility, or, you know, it's easier when we talk about businesses because then we just say total revenue. But when we're talking about individuals and stuff like that, it gets to be a little bit more ephemeral, if that makes sense. It's the increase in your total benefit that results from doing one more of that thing. And again, you know, just like with costs, our average benefit is equal to our total benefits divided by however many units we're doing. So let's go ahead, and with a lot of this stuff, the best thing to do is to do an example, right? So we'll do a quick example, and then we will switch over to Chapter 2 and talk about comparative advantage. So we've got SpaceX rocket flights, and we're trying to figure out how many launches should they make. And in order to figure that out, we are given some information. We're given the schedule, essentially, for how much it costs for each one of these launches. And so obviously for 0 launches, it's going to cost $0, right? These are all in billions. For 1 launch, it's going to be $3 billion. For 2 launch, it'll be $7 billion, 312, 420, and 532. So how would we figure this out? Well, number one, we only have one side of the equation, right? We only have a schedule for the total costs, right? So we need to figure out what the total benefits are. And so we're told in the problem that every launch, the marginal benefit is $6 billion per launch. So just a flat $6 billion per launch. So how do we figure out how many launches we should do? And so this is when that incremental analysis comes into place. I don't know why I said, oh, because it's in billions. Got it. 6 billion. Cool. So in order to figure that out, we have to get, firstly, our marginal cost. So we'll abbreviate that as MC. And again, this is going to be in billions. And so the marginal cost of going from -1 to 0 doesn't exist, right? So the marginal cost for 0 is always just dash. It just doesn't, it's not defined. The marginal cost of the first one is the increase in the total cost divided by the change in the number of units. Now, this is all just going up by 1, so we don't have to worry about the divided by the number of units, right? We can literally just say, okay, this is my total cost of 1 minus my total cost of 0. And so this ends up being 3 minus 0. So this whole thing ends up being 3. My marginal cost is 3 for my first launch. For my second launch, now I'm using my total cost for that second launch minus the total cost of the first launch. So it's going to be 7 minus 3, which is going to give us 4. So the marginal cost of the second launch is 4. We do the same kind of thing in terms of total cost 3 minus total cost 2, which is 12 minus 7. So this ends up being 5. The marginal cost for the fourth one is going to be 8, and the marginal cost for the fifth one is going to be 12. So now that we have this marginal cost information, how do we make up our mind, right? It's not apparent right now because we don't have a total benefit column or a marginal benefit column to really kind of replace it or to compare it with. So let's go ahead and let's clean this up a little bit. Let's get rid of some of this extraneous information. So this is dash 3, 4, 5, 8. 8 has an extra loop just for fun. Why not? Looks like a little caterpillar. All right, so now we need to figure out marginal benefit, right? In order to do our incremental analysis and figure out what is that optimal number of launches, right? We're asked how many launches are optimal. And so anytime we're asked about how many of things or the optimal amount of things, we're going to be using this formula, which is essentially saying that we're going to set our Q star where the marginal benefit is greater than or equal to the marginal cost. So the last unit where the marginal benefit is greater than or equal to the last cost. So let's go ahead and put a new column in here for our marginal benefit, also going to be in billions of dollars. And for this one, again, what's the marginal benefit of 0 launches? Doesn't exist, undefined. What's the marginal benefit of the first launch? Well, we're told it's $6 billion per launch. So this is literally just a column of 6s. Every single launch, the benefit is 6 billion, extra 6 billion. If we wanted to, for completeness, right, we could go ahead and we could make a total benefit column over here, which would be 0, 6, 12, 18, 24, 30, right? Because essentially all we're doing is we're taking this marginal benefit and we're multiplying it by the number of launches because the marginal benefit is the same as the average benefit for this particular thing. So now we're set up where we could do our incremental analysis. We don't need that total benefit on the side. That's completely unnecessary. It's just for completeness. So what we are going to do is we are going to, so this is where the marginal aspect of it or the incremental aspect of it comes into place. We're not going to be looking at things on the whole. We're going to be looking at things in terms of where we are right now and if we want to go forward one step. So we start off with 0 launches. And we ask ourselves, do we want to launch 1 rocket? The marginal benefit is 6. The marginal cost is 3. Yes, we want to go ahead and launch that first rocket, right? Anytime the marginal benefit is greater than the marginal cost, we're going to go ahead and we're going to launch that rocket. So when we go to the second rocket, are we going to launch it? The marginal benefit is 6, the marginal cost is 4. So yes, we're going to launch that second rocket. Are we going to launch the third rocket? Well, the marginal benefit is 6, marginal cost is 5. Yes, we're going to launch that third rocket. Are we going to launch the fourth rocket? No. The marginal cost is greater than the marginal benefit, and so that we stop at 3. So our Q star for this particular example is going to be 3. Does that make sense to everybody? Again, I have a recording of this. I'll put it up on YouTube so you'll be able to stop it and slow it down or rewind it or whatever the case may be later on. But this is an important part. We're going to be using this kind of thing a lot. So I highly recommend getting some extra practice if this is not clicking for you yet. It will. It just takes a little bit. Okay, awesome. So that's going to be the end of chapter 1 lecture notes. Let's go ahead and jump into chapter 2. Chapter 2 is all about comparative advantage. So comparative advantage, we're just going to dive right in and talk about what the principle of comparative advantage is. So the principle of comparative advantage is that everyone does best when each person or country concentrates on the activities for which their opportunity cost is the lowest. And so, again, with most of these things, right, a definition is great, but it really doesn't click until we actually get in and do an example, right? And so the gist of it is that we've got multiple people faced with multiple tasks. How do we assign the work? And so the principle of comparative advantage says that we should assign the work based on where the opportunity cost is the lowest. And so we find out in the end by using specialization in trade, specialization just meaning like if you're good at something, you are concentrating on doing that thing, and trade, so being, if you specialize on just making bread, you're trading with somebody so that you can have bread and milk and stuff like that, right? Through specialization and trade, total output can increase. So using the same amount of resources and the same amount of time, by specializing and trading with one another, we can make a larger pie. We can have more stuff. So let's go ahead and do an example. So we have two people, Jin, Xin, and Anna. And so we're told that they can either update web pages or repair bikes. We are given this following table that tells us about their abilities. So for Anna, it takes her 20 minutes to do a web update and takes her 10 minutes to do a bike repair. For Chin, it's 30 minutes for web update and 30 minutes for a bike repair. So firstly, when we take a look at what's going on here, we can see that Anna is better at both things than Chin, right? Anna can do the web update in 20 minutes compared to 30 minutes, and can do a bike repair in 10 minutes compared to 30 minutes. And so from this, we can conclude, okay, Anna has what's called the absolute advantage in both. But really, at the end of the day, we don't care about who has the absolute advantage, right? Like, that's cool and all, good for Anna, but we want to know, how do we divvy up the work so that we can get the maximum amount of output given the same amount of resources? So in order to figure that out, we have to figure out who has the comparative advantage in what. And so in order to do this, we have to look at the opportunity costs, right? So how many bike repairs is Anna giving up every time she does a web update? So now we're going to look at opportunity costs instead of production times. So how many web repairs does it take, how many bike repairs, sorry, is Anna giving up when she spends 20 minutes updating the websites? 2. Very good. 2 repairs. And so similarly, how many website updates does Anna give up when she repairs a bike? It's kind of weird because you don't actually do this, but she does half an update. So we are going to deal with some fractions and decimals here, even when it doesn't always make sense, right? And then for Jen, it's really easy, right? The opportunity cost, since it takes him the same amount of time to do web updates and bike repair, he's giving up 1 repair to do a web update, and he's giving up 1 update when he does a repair. So now that we look at this, now that we have it in opportunity costs, we're going to take a look at each particular job and say, who has the lower opportunity cost when it comes to web updates? So this is where it gets tricky too, because this is a golf situation, right? Lower is better. We're used to always thinking higher is better, especially with economics and money and things like that, right? You know, more money is better. But in this situation, remember, it's opportunity cost. Costs need to be low. So we're looking for the lower number. So within the domain of the web repairs, who has the lower number? Zin, right? So Jin has the comparative advantage in web repairs. Whereas if we were just to look at the bike repairs, who has the lower opportunity cost when it comes to the bike repairs? Anna, right. So the answer to this question is we're going to have Zin do all of the web repairs, and we're going to have Anna do all the bike repairs, since that's what they have their comparative advantage in. Now, let's go ahead and really prove this to ourselves. So in order to prove this to ourselves, we have to do one more of these stupid tables, right? Which I know we're all loving. We got to do one more of them, because in order to figure out did we actually produce more by specializing in trading, we've got to figure out what's the hourly output for each one of these people and what they do, okay? So we have one last table that we need to make, and this one is going to be our hourly output. And so, for this one, it's actually easier to go back to the first one, right, and kind of ignore the one in the middle. So for this one, we know that it takes Anna 20 minutes to do web repair. So how many web repairs can she do in an hour? Well, 1 hour, 60 minutes divided by 20 is going to be 3 updates, right? Everybody cool with how I got that? So since it's hourly, an hour is 60 minutes, we're going to take these values, we're going to divide by them, and we're going to end up, that's how we got that 3 number. So likewise for bike repair, right? If it takes 10 minutes and there's 60 minutes in an hour, she's going to be able to do 6 repairs. For Jin, it doesn't matter. It takes him a half hour to do everything. So in an hour, he'll be able to do 2 of anything. Okay. So now, we're going to hypothesize that 16, oh, you guys can't see that at all. Better. That 16 web updates are ordered. Can I increase my brightness here? That does not do anything to you guys? Nope. Okay, cool. Good to know. All right. If we have Anna spending, so we're going to first off do before specialization and trade. We have each one of them just kind of doing half and half, right? So Anna spends half her time, her 8-hour workday, at each activity. And so since it's a 8-hour workday, right, that means that Anna is going to spend 4 hours doing web updates and 4 hours doing bike updates, or bike repairs, bike updates. I need to update my bike. So in 4 hours of web repairs, if you're Anna and you do 3 updates an hour, your total number of updates is going to be what? 12 updates. Likewise, if you do 6 repairs an hour and you're Anna, and you do 4 hours, 4 times 6 is 24 repairs. There's a point to us doing this, I promise. It's like, why are we doing this? There's a point. So then we are going to have, in the same scenario, right, we're going to have Chin doing the remaining, he does the remaining 4 updates, because remember, only 16 updates were ordered. And so 4 updates, right? That's gonna take Chin how many hours? Very good. And so with the rest of those 6 hours, so 2 hours for 4 updates, and then 6 hours for 36 updates. Oh wait, sorry, 12 repairs. Right, because 6 times 2 is 12, 2 times 2 is 4. Okay, so now we have the situation where there's no specialization and trade, right? And we end up with a total of 16 web updates and 36 repairs. Now, what if we were to specialize? Well, if we were to specialize, right, what did we conclude up above? We said Jin should do all of the web repairs, and Anna should do all the web updates, and Anna should do all the bike repairs. So if Jin does all of the updates, so 16 updates is going to take him all of the 8 hours. And if we have Anna use all of her 8 hours in bicycle repairs, then this is going to give us 8 times 6, which is 48 repairs. So same amount of time, but by specializing in trading, we end up with, we went from 36 repairs to 48 repairs. So we end up with 12 more repairs for the same inputs. All right, that'll do it for today. I'll go ahead, I'll throw this up on YouTube so you guys will be able to take a look at it later. The activity on Friday will be directly about comparative advantage and specialization, so you have a chance to practice this. If you have any questions, feel free to email me, set up an appointment. Have a great week, guys.